I think we can get into that one.
Let's not waste that. That's a good question. We don't want to waste it. Don't want to waste them here.
Yeah.
Hello and welcome to episode 55 of Great Things with Great Tech, the podcast highlighting companies doing great things with great technology. My name's Anthony Spiteri, and in this episode, we're talking to a company that was founded just recently in 2019, recognizing that the manual process of traditional security operations was ineffective in this rapidly changing cloud world. A company that's making threat prevention and security operation available via a platform that provides early and accurate metrics and visualizations through recognition of attacks, providing companies with an unprecedented level of intrusion prevention and mitigation. That company is SpyderBat, and I'm talking to Brian Smith, co-founder and CTO at SpyderBat. Welcome to the show.
Hey, thanks. It's great being here with you, Anthony.
Excellent. All right, then. So before we get into all things intrusion detection and security in this crazy world that we live in, just want to give a shout out. If you love great things with great tech and would like to feature in future episodes, you can click on the link on the show notes or go to GTwGT.com, register your interest. And as a reminder, all episodes are available on all good podcasting platform, Google, Apple, Spotify, all hosted and distributed by Anchor.fm. Go to YouTube as well, hit that like and subscribe button. And with that, let's get into the show. So Brian, just firstly, let's talk about SpyderBat, but I want to find out a little bit about you first, where you came from. You've had a really interesting, last, 20, 30 years in IT and technology as a founder. So give us some background there, and then, tell us about what got you to, go through it again and create SpyderBat.
Yeah, I think, getting me to go through it again, this is my third startup, and it sort of reminds me of like people who go get their PhDs at school. Some people never learn.
That's a good one.
Which I can say because I got my PhD from Berkeley, and then I was a professor at Cornell for about 5 years, and then
okay.
went down into in the computer science department. Yeah, that was a really neat run, and then I started a company down in Texas with a bunch of other people called Tipping Point. And that was around 2000, 2001. And that was doing the first intrusion prevention systems, which were kind of network intrusion prevention systems.
Okay.
And so I can tell you more about Tipping Point, but anyway, out of that company, we got to see a lot about how people came to us with a lot of really interesting problems of, how do I protect this? And we always took them with a, view of how do I solve them with the stuff we have. And a lot of them we could do, but a lot of them was, ooh, that's a toughie. And that company was sold to 3Com.
Okay.
We started Click Security as my second company out of that. After that in 2009, that was sold to Alert Logic. And that you can think of that as an early day XDR. And then SpyderBat was founded in 2019, and we got our seed round funding in around July 2020, right in the middle of pandemic.
Okay, yeah.
And went after trying to use a lot of what we had learned over the years to secure cloud and Kubernetes and Linux workloads, because there's just Linux is being used for everything.
That's it.
In the cloud, and that's where the crown jewels are. And yet the security solutions, there's just a dearth of good security solutions out there for a variety of reasons. But
yeah,
so actually, that's where we saw a lot of opportunity.
Actually, so I just noticed that you just got your Series A as well, didn't you? So that's pretty good.
Yeah, we closed on our Series A
on
we announced that in October. So we're that was a $10 million round. So
there you go. So there might be something in this.
We definitely think so, and so do our customers. It's a fun run. I'm really excited about what we're doing because it's so different from kind of the state approach that we've seen before.
Yeah, and I got to ask, where'd the name come from?
Yeah, no, that's a good question. So naming companies is kind of fun. So we're out of Austin, and so Austin has this thing called this bridge called the Congress Avenue Bridge, which goes over the water, and it has the largest colony of bats in North America, these Mexican free-tailed bats.
Oh, okay.
Millions of the things live underneath the bridge. And so Austin's known with bats. And so we thought SpyderBat would be a fun name just because there's these bats that eat spiders are spider bats. But when we went to open the bank account, the bank teller misspelled SpyderBat with a Y.
There you go.
Instead of spider. And we thought, oh, that's pretty cool. And so we actually changed the name of the company. We just filed the incorporation papers. And so
that's awesome.
We changed it. And that's how SpyderBat got to be.
Yeah, I was gonna say with the Y there. That's an awesome origin story. I was in Austin this year. Yeah, I think in July, and I didn't even go to that bridge. That's interesting. So next time I go, I'll have to take a look there.
Awesome.
I loved Austin. It was a great city.
Yeah, if you go out there at sunset, you just on the edge of the bridge, you can see just millions of bats pour out, eat all the mosquitoes. It's awesome.
I missed a trick. It's actually funny about that Y and the misspelling. My daughter actually, her name's Lorelei, and at the end of that name, because it's a bit of a weird one, my wife misspelled it when she was born. Instead of IE, it was EI, and we just stuck with the misspell because it was just easier because it was written down. So there you go. Interesting little segue there. All right. So going back into it. So you've talked about, the problem that you're trying to solve around security, around containerization as workloads are moving, from traditional on-prem virtual machines. But you're still basically, you said to me earlier, anything Linux based, right? So what's the problem statement? What are you guys trying to solve fundamentally at SpyderBat?
So there's really two parts to it. One is that good security, the foundation of good security is kind of knowing what's going on at runtime in your environment. And if you look, there is a dearth of good solutions that let you know what's really happening at runtime and that are able to react and stop bad things from happening. What typically happens in most attacks is the attacker will get in through some vulnerability or some weakness in the system, maybe even stolen credentials, things like this. And they'll get a foothold in the system. And the very first thing they do is they start looking around because they've got these, they're on this new system and they're not really sure where they are. So they start poking around. Most of that activity is recon activity that they try to set up persistence so they can get back in case they get knocked out. And all that activity usually goes undetected. They continue to kind of case the joint and figure out what's going on until they actually start launching the attack. And usually it's somewhere around 2 months on average that they're in the system. Before you actually detect them. And that's just like a travesty. Because they're on our turf and we should be able to detect them. They're making noise. And
that's a violation, right? Yeah, they're violating the sanctity of your company, of your network, of your people. So it's actually scary.
So what we wanted to be able to do was detect them just right of boom, from right the moment that they got in, and then be able to tell everything that they did on since they had been in. Maybe you detect them 12 hours in, and they set up a little bit of persistence. But if you were like sitting on the shoulder of the attacker as they were going through it, and that's actually how some people have described SpyderBat. It's like sitting on their shoulder as they're pivoting and moving through your network. You can see everything they touched, everything they did, prevent them from doing damage, and clean up the mess. And it's really, really fast to do that. So it's basically click on an alert and you get a picture of exactly what's going on and how to stop it, and how to undo any damage that's been done really, really fast. So it takes this thing that's 6 months of work down to 5 minutes.
That's really impressive.
I can get more into how that works, but
no, that's cool. Yeah, we might dig into it. We might dig into it a little bit, but I think from that point of view, what I've seen, obviously, you've got the UI that you guys provide, and there's all sorts of dashboards. It's a very nice UI, actually gets to the point. But then I saw a demo of it that showed that, it showed, someone doing some stuff like elevated privileges, trying to get elevated privileges to a certain machine, snooping around. So it actually showed you, what was happening on the system itself, and saying, this is not normal, have a look at this. And there's the alert, like, this isn't what we think is normal behavior in a normal operating environment. And then you've also got these causal visualized graphs, which basically, from what I can see, give you a node down or a node up, whichever way you're looking at, view of the system to show you what's actually happening at the different levels. So it's really cool, and it looks like it's intuitive as well. So that's a hard thing to get right when you're only 2 and a bit years in, really.
Yeah. I think, I mean, it's one of the things that we did was we made it open for other people to try. And so we took several attacks that like a Log4j attack and from a honeypot, and some real attacks, and some defend the flag type challenges. And what we did was we put those up so that you can actually explore the system. You create a free account and you click on defend the flag challenges, and you can actually play with the UI and see what a Log4j attack looks like in action, or see what different types of attacks. And you'll get a sense of what you're talking about, because what you were describing there, the causal graph, the notion there is the real problem of security is it's a little bit like debugging, like reverse debugging. You see something happen, that's your alert, your initial signal that something's going on. That's like the bug happening. Yeah. And then there are a bunch of things that cause that bug to happen. And what you want to do is work your way backwards. What caused this? Well, this file got written. Well, who wrote the file? Well, that was written by this program. Well, how the heck did that program get going? Well, that was that program was installed over here, and it was pulled down from S3, and that S3 file was written by this other program up on this other system where the user SSH'd in and copied it in. So all that activity of, from the beginning, from when the SSH happened to copying it up to S3 to pulling it down to starting another program. Yeah. Those activities are a causal chain. This caused this to happen, caused this to happen, caused this to happen. Makes sense. So if you can start at the point and work your way backwards, we provide that backwards linkage. And that's what I mean by you click on it and you get back, 4 days ago, this is where it started from. That's now, most of the time that you get to see it, 30 seconds later or a minute later, but because the attacker's in there, they're constantly doing things that trigger more and more activity. And so you get multiple bites of the apple before.
And the attacker wouldn't have a clue that you're effectively spying on them. You know what I mean? You've got spyware on them. That's a great way. That is actually really interesting. So you've created almost the inverse of spyware, but it's still kind of a spying situation. It's proactive and reactive at the same time. It's interesting. I want to dig into how you do it, right? And there's some really cool, and you're leveraging some cool Linux technology in kernel to be able to do what you're doing through Nano Agents. Just before that, you talk a lot about shifting left. And I've heard this. I was at reInvent 2022 last week. I heard a lot of this shift left, talk. So just give us a little bit of a background as to, what shift left is and where you guys fit with that, and how you're trying to sort of shift them a little bit more right. So just go through that.
So there, it's a good topic. The notion of shift left is really trying to catch security problems as early as possible in the life cycle of software. So the earliest possible, the best way to do it, the theoretically best, is to ship with no bugs. It's because really software vulnerabilities are just bugs that attackers can exploit in some way to do something that you never intended to do. Anthony, if you think about what hacking is understanding how something is implemented so you can use it in a way that it was never intended. That's like, people say hacking the genome or hacking my car to get it to start. Yeah, something exactly. Like that. It's understanding how it works to make it do
something it doesn't do. That's right.
Yeah, exactly. So, so the theory is that if I could prevent every vulnerability before it entered the software, the attack surface would be smaller, so it would be harder for attackers to get in, and that's a great, it's a laudable goal. The problem is that it's incomplete, because you're still it's like saying that I ship with no bugs. What software that's an impossibility that's ever shipped out there that has 0 bugs?
Impossibility.
Not just 0 known bugs, 0 bugs, period.
Yeah. And never any moving forward. I mean, when we haven't gotten to the stage where we've got, though this week it's a bit topical, where AI is writing code for us, right, as we ask it, but we haven't got to the point where that code is perfect, and it will never be, because it is fundamentally flawed, because humans do create it. So there's always going to be a fundamental challenge with it.
Well, and so, so what, as soon as there's bugs in the program, because you can have unknown bugs in the library, you can have known bugs in the library, you can have unknown bugs in your code, you can have no bugs in your code and still have combination of features that conspire together to allow the attacker to do something that you didn't want them to do or expect them to do. And so all of those reasons mean that you need a portion that is monitoring at runtime.
Yeah.
What's actually going on, detecting bad things, and shutting them down is just right of boom. And that actually ends up being a much more practical way to solve the problem, because what's happening, what happens if you try to squash absolutely every vulnerability is that you spend an inordinate amount of time trying to defending against theoretical attacks where in practice they actually could never happen.
Yeah.
And so it's just kind of slow and inefficient, whereas a more practical way is to have a compensating control that can detect the attack, kill it, tell you about it, and with enough details present that you can go back and prioritize the problem that caused that to the vulnerability in your software that allowed that attack to happen.
Yeah, this is the whole concept of runtime security.
Blocks it, but still fit it back into the software development lifecycle like that to fix the problem. It's not an excuse for not fixing the problem.
Yeah, I get it.
It just gives you a really good way to prioritize the problem.
It's logical, makes sense. Yeah, it's logical.
Yeah.
It makes sense. So this is this concept of runtime security, right? Like I think that's kind of really what it comes down to. But what you explained is very interesting, because obviously there are companies out there that will go, on the left side of that, if pardon the pun there, but basically try and hit it and make it perfect before it goes into production. But like there's all these unexplained vulnerabilities, all these hidden ones, and you're never going to be able to detect all of them. You're correct. So being able to be proactive and reactive in the actual runtime when things really are on deployed and actually in motion is the way to do it. And I think that's a really interesting and unique approach, and one that I don't think I've seen elsewhere in the market today. So that's good in itself.
The other benefit you get out of it is once you have the system that can tell you, why this thing happened, it helps you with the operations side too. So we have customers who the security group gets involved because a Kubernetes cluster got deleted and they think they're under attack. And so then the security group spends, does the weekend fire drill and spends 4 days crawling through logs and found out that it was 6 levels down in scripting that someone fat fingered and had an environment variable set wrong, and it invoked a command to delete a cluster. So it wasn't an attack. Most of these things end up being friendly fire incidents.
Okay, yeah.
But the security group just spends ridiculous amounts of time trying to chase this stuff down by looking at logs, and it's a terrible job. It's no fun at all.
That's why it's a very special type of person that does security. So there you go. Is their main focus. But this is the concept of bridging DevOps, from my point of view, platform operations and whatnot and SecOps. So you're kind of trying to bridge that together, but not have it connected in a way, right? So I think that's what you're kind of getting at. You're trying to make the security guys' team a lot easier while making it more of a function of dev and platform, right? SREs.
Well, yeah, I mean, if you look at the two problems are really closely related, because a lot of what DevOps does is investigating the system's not behaving the way I expect it to, and trying to figure out the root cause. A lot of what security guys do is I have an indicator of a possible attack and trying to figure out root cause. And so that's really what SpyderBat is what we found out is we could record everything that happened on the system and link it together causally to build a map that matches what's in the user's mind of how computers work. Processes read files, write files, processes make network connections, processes start other processes, and how that one thing causes another. Then you can solve both problems with that. It's like we have a tape. It's almost like a DVR of everything that happened on all of your systems and how they interrelated. And so you just roll the tape to figure out what happened. And then the problem you run into is it's too much data. But the causal tricks is the one that gives you the answer to that, because you start with the effect and work your way back up the causal chain, and then you know exactly why it happened.
Yeah.
So that's the theory, and we've been working on it for 2.5 years, and we've actually figured out how to do that thing.
Yeah, no,
it
definitely sounds that way, right? So in terms of how it's delivered. So let's go into a little bit about how you're delivering the platform today. At the moment, it's SaaS based. So you log in, you've got your UI, and then it deploys this concept of Nano Agents, which is using eBPF. Which for me, I had to do a bit of research on that, being honest, and finding out exactly what that was. It's like it's got its origins in the Linux kernel. It basically runs a sandbox program inside the operating system kernel. So you're plugged right in there, and it's from what I've done the research on, it's a really safe and efficient way to extend the capabilities of the kernel without changing it. So how did you get onto that to use as these Nano Agents, number one? And just tell me a little bit more about that, because I find that quite fascinating.
Okay, yeah. So the concept of the Nano Agents is pretty simple. They're a small software agent that runs in user space that installs these little plugin modules we call bats, little programs.
Okay, there you go.
That gather data from the endpoints, and guess what? They come from the Bat Cave. Yeah. so the Nano Agent downloads these bats, and the bats gather data from the endpoint. So the basic concept I wanted was, we have an analytics that the bats ship their data through the Nano Agent to the backend, to the SaaS backend, and then a set of software on that, call them analytics, run our detection, build our models and run our detection. So if I, as a security researcher, want to detect a new attack, what I do is I say, it would be really easy if I had this data. So I write a little bat to gather that data and then feed that back to the back end. And because I have exactly the data I want in a very regular way, I can, it's very easy to write the detection that's accurate and effective. Whereas most other, if you look at systems that try to do that from third-party data logs, it's really a rough place to be, because usually the data is not there, or if the data is there, it's so twisted in a way that you can't be accurate. And that's why that's the historical problem of SIMs. So getting back to your question, some of the bats we have are using eBPF. And when we originally started this, we tried to use some of the other capabilities, like the Linux audit system that's built into Linux kernel. And it was just crushing the box, because it was from a performance standpoint to log the data we needed.
Yeah, I understand. Yeah.
Plus, it wasn't as extensible as we wanted. So eBPF gave us a chance to say, I want to, for example, track the life cycle of every process, from when it's born, as it mutates, and then when it dies. And so with the eBPF, we can intercept the function calls in the kernel that where the process is born, where it mutates, execs another program, changes user privileges, stuff like that, and dies, and send those as very lightweight events to our Nano Agent. The net result of this is we have some that track all the network communications, another one that tracks all the file accesses. Now there's a look at DNS requests. Now there's a bunch of various bats that solve different security issues for us. But the eBPF method gives us a way to almost extend the kernel for what we want to do, the data we want to gather, and do it in a way that has almost no performance impact on the box. It's like usually 1% to 2% of the total load of the box on this, and yet we're gathering all the data we want, and it's a very lightweight amount of data. In fact, it's about 100 kilobits up out of the system going back to the back end.
Okay, just before I go to the back end, just a question that popped into my head there was, obviously you're correct, because if an attacker or a malicious user was on a box and they were doing their research and doing their reconnaissance and waiting 2 months, if they happened to see, if they had HTOP running and they saw the spike of CPU or activity on the disk, they would get a little bit, they're smart enough to go, that's a bit weird, and maybe they will catch on. So the fact that you're not triggering significant overheads on the system actually makes the spyware element that you guys are doing, more real. I'm assuming though that these bats and the Nano Agents, they're not able to be seen by anyone on the command line. You know what I mean? So if I go into a HTOP and see, they're basically invisible, is what I'm trying to ask.
They're obfuscated because they're running in user space. They are in fact visible, but they're obfuscated and protected. And we monitor it on the back end so that essentially you want to know if the nano agent gets killed. They're hard to kill because we use a lot of the same techniques that that viruses and malware uses to prevent itself from being killed. So it's pretty hard for the attacker to kill. It brings itself back, and then that itself, they do somehow manage to kill it, that itself becomes a signal that
something's
you
going
want to
on.
investigate.
Yeah, and I guess
usually by the time they've got that, they've done so much recon that we've already identified them. And
interesting.
You know what's going on.
Yeah,
because all that data is already in the back end.
That's it. Yeah. And it's a massive red flag if they kill it as well. Like straight away, it's okay. Someone's doing some.
It's sort of like it's sort of like if you're in a bank and there are security cameras and someone's rummaging around the bank and going through all the drawers, and then they look up at the security camera and take out a gun and shoot it. And all that footage is back at the back end. It's not like there's any ambiguity of what's going on.
So in that back end, so when you're shift, are you in real time? Sort of, obviously, you're taking the event or whatever you're looking for through the bats, and you're sending that data up to the platform. Is that like a pooled? Are you pooling all of the data together to basically get some economy of scale with regards to the data that's in there, and then basically running? I know you've got the labs and the research arm that are part of this, but is that going into a particular user's pool of data? But I'm not sure where you're storing it, wherever you're storing it, or does that then go into a larger pool to basically maximize the amount of info and data points that you're actually getting?
It goes in. We divide the world into organizations because those are customers, and each organization is firewalled off from the
separated.
Other
that's what I was getting at. Yeah,
right. So it's kind of natively multi-tenant. So we get economies of scale for that. What happens from the nano agent is we batch up small batches of events every 5 to 15 seconds. We send them to the backend. They take about 3 to 5 seconds to make their way through our analytics system, and then they're live. So what you're seeing on the screen is about 20 seconds delayed, cool. Anywhere from 10 to 20 seconds delayed of live. So it gives great demos because you sit there, someone logs into a system and then starts typing commands, and you can watch the commands on the screen as they're doing it. And see
that's very cool.
Doing.
Me working in the
which is the same.
Yeah, I was going to say, me working in the backup space, my brain's ticking away in terms of the potential for this, because we obviously deal with the back end of that situation when something's gone really wrong and they've got to recover it, but there's always a problem of how do you stop that from happening, like it's an end-to-end type of play, right? So yeah, it's really interesting.
I'll tell you a story that happened to one of our customers on the operations side. I'd give an example. He went in and he got an alert. He was running Darktrace among other things, and that detected the spike in network traffic between two systems. It was an abnormal spike, and it was going between a server and the backup system. And so he basically looked up the alert and not the alert, the network connection in SpyderBat, and found it was coming from a program that had been launched by a script. And he could see all the other script commands of where it created a tarball, seeded in a directory, ran a command to compress the file, seeded in another directory, and then copied it out. And there was a bug in it where he looked at the script and it had just been installed the day before. He could see exactly who installed it. And there was a bug in the script where it was seeding into the wrong directory before it did the gzip. So the file was never being compressed.
Okay, yeah.
And so it was the uncompressed file going out.
Yeah.
The backup script had just been updated. He saw who updated and when he updated it. This whole thing took him like 3 minutes. And he called the guy up on the phone and said, hey, that script you installed the other day on this system, there's a bug in it. You CD'd into the wrong directory and it did. And so you're not compressing the files being sent to the backup.
Wow.
And the guy's like, how the heck did you figure that out?
Like, you watching me, man? Are you watching me here? Like, what's going on?
Yeah.
That would have been a bit
so
freaky.
But it was really straightforward, It's not.
I was going to say SpyderBat Labs as well. So talk to me a little bit about that and how that fits into the puzzle of what you guys are doing. Yeah.
So if you think about an attacker getting onto your system, and then they start rummaging around, there's a whole matrix of things they can do. And a good place that tracks this is the MITRE attack matrix. if you've heard of that. It just basically tracks tools, techniques, and procedures that attackers use. And a lot of them are really low level things that you wouldn't care about. Someone running, I mean, as simple as running who am I, or PS on the box to figure out what processes are running, or commands like this, just very simple recon commands, pinging a host. And what you find is that if you can detect those low-level things and then causally relate them, that this and this and this were all part of the same session for this user, you can score them together as a group, and that collection of low-level signals makes one really strong high-level signal that something weird's going on.
Yeah.
It's sort of like detecting 43 proteins that float around in your blood, but correlated together, there 25 of them are associated with a particular form of cancer. You probably got that cancer. So it detects that inside the system. Sonar Labs is all about building the security content that detects those things, low level, high level, and gluing them together to make very accurate ways to detect attacks, and use this recording technology very practically for attack detection technology.
So that's basically that is what makes SpyderBat, right? The smarts that are in that particular lab to detect it. You've got the great technology that's the Linux-based Nano Agents there, which you mentioned actually quite interestingly is kind of architecture agnostic, isn't it? Because you're mentioning you've installed it on Raspberry Pis and whatnot, which is cool because those things and the ARM processors are making their way into our networks, into our edge locations, and just data centers in general. So the fact that you're able to be architecture agnostic is a big tick. I am interested though in the Windows side of it, because obviously there's lots of obviously in public clouds. You cross AWS multi-cloud, you containerized workloads with Kubernetes, but Windows is still there, right? So how do you, if you got a customer that comes to you and say, hey, I do have a lot of Linux, but I've also got these Windows boxes. Like, what can you guys do for me?
Well, so we're a startup, so you have to pick where you're focusing, where you're going to be great at. And so we've been focusing on the Linux side of the equation. People tend to have fairly mature security processes around Windows and Linux, and big investments in them. We have techniques where we can get the same type of data out of Windows, but we haven't gone to the effort of commercializing those yet, because there's such a dearth of stuff available for the Linux world. If you ask people, to what visibility they have into the real runtime workloads that are happening on their Linux servers and in their Kubernetes boxes, and compare the security there versus the maturity of security they have in the Windows and Mac things, it's really weak. And so we're focusing on filling that niche. And we'll get to Windows once our customers demand it. But they're telling us right now, focus on the Linux box, because that's where I'm completely blind.
Especially with Kubernetes, which is still so new and fluid as a platform, right? And it's always changing. And I think Kubernetes is inherently a black box. Like, there's very few people, especially in the DevOps world, they'll just kind of deploy their applications. They get the namespace, they've got the artifacts, and they kind of do their thing. But I don't think a lot of them really care about how that happens and how, what's happening. Whereas me and a lot of the platform guys are really still interested in, okay, what's the CPU doing? What's the storage doing? What's the network doing? So that level of understanding, I believe, is getting lost to a certain extent as more workloads shift to containerization, cloud, and whatnot. So you're absolutely correct that the addressable market in that space is significant, because it's Wild West still for me. There's so many tier 1 applications going out there. Enterprises are adopting Kubernetes more and more, but honestly, I feel like they are like lambs to the slaughter at the moment without this sort of technology.
And the Kubernetes thing is a great example of the nano agent architecture, because what we did was we built a bat that we call it the Lighthouse Bat, and it goes off and monitors the Kubernetes environment, just monitors both the container through the container interface and the Kubernetes audit interface, we're able to inspect the Kubernetes environment and tie that back to what the physical processes are on the machine. So every process on the machine, I'm able to map back to a Kubernetes pod namespace deployment. But then I can also visualize exactly how, for example, a Kubernetes rollout happens.
Yeah.
From watching the containers be pulled down, a new set of containers go up, and the network traffic between all the containers and the actual processes on the containers. Once you have that, a really neat thing happens. If you think about the average, kind of microservice, it's really is micro. It tends to have just a few programs running in it, and it talks to a few other services. It gets, requests from a few services. It talks to a few services, and it's pretty tight of what it does. We're able to look at multiple runs of those because they run off the same Docker image or same image.
Yeah.
And build behavioral fingerprints of each one and combine those together to create a behavioral baseline that's human readable, that says these are all the processes that are run in the process tree that gets created. These is all the ingress connections, egress connections. Once I have that as a developer, that can be integrated into my workflow, where every time I roll out a new image, I get a new just by deploying it in my integration environment, I get a new fingerprint from it, and I can compare that against the baseline and see if anything's changed.
Yeah.
This allows you to detect things like supply chain attacks, unexpected behaviors when you upgraded the libraries, or anything else, because something new happens. It's talking to a new service. It's launching a new program, and you have no idea.
Yeah, I get it. Yeah, that's really cool.
So we're able to see, tell the developer about it, and then they say yes or no. And if it's expected behavior, they say yes. That thing can then become a contract, or something I can give to the security group and say, these are the guardrails for my application. This is how it should behave at runtime. And if it doesn't, shut it down or let me know, or anything else. And it reduces operational issues, and it also provides really, really good security, because now instead of trying to detect attacks based on the known attack technique, we're able to, essentially put a padlock around this container image and say, this is the guardrails for it. And if it ever deviates, shoot it in the head.
Hey,
and we'll move on.
That's interesting. And also, just to finish off, we're kind of rapidly running out of time here, but do you have extensibility and the ability to plug into, ecosystem partners and whatnot? So actionable items. So if something happens, obviously you've got the UI, but can they plug into the API and basically insert it into a pipeline or something, or even just plug it into some other system to do actionable items afterwards? Because I think that opens up a tremendous opportunity.
Yeah, there's multiple avenues for that. First off, you can get it's all an open API. Everything that's done on the console is available through API calls through a well-documented API. So everything's automatable at that level. Secondly, we have the data you can get out of it is pretty easy to understand and parse. So you can use that for your own purposes and import it into, we have connectors for all the usual, Splunk, Elastic, the usual suspects. And then the third thing is we can attach for any given detection, we can attach actions to that. That can be everything from things the Nano Agent does on your behalf, like killing processes or pods or things, or invoking webhooks, which might send a message to to a Slack channel, or invoke scripts on your side, and that's all extensible as well. So you can install your own scripts to do things on the client side, or invoke them on the back end.
Excellent.
So you can automate a lot of security.
Yeah. Well, hey, we could have chatted for a lot longer. The time is short now, but hey, great conversation. I think, to be fair, the people are going to understand the greatness of what SpyderBat's creating. I think you guys are onto a really great thing, and I wish you all the success as you move this startup into a very, very competitive world. But thank you for being on the show. Just want to finish off by saying, if you like great things with great tech and would like to go on future episodes, please once again go to GTwGT.com. You can find me at Anthony Spiteri or at GTwGTpodcast.com. With that, thank you, Brian. Thank you, SpyderBat, and we will see you next time on Great Things with Great Tech.
Thank you, Anthony. Great talk.
Awesome. We're going to cut off in about 2 seconds.